Hey there, and welcome to another channel video. GVDA sent me another product for review, and this time I have it here for some weeks waiting for the review, and I'm talking about the GD166B digital clamp meter. I've been testing this device for a few days, and I'm pretty excited to share with you the results of the tests I've made. But spoiler alert, I'm impressed. Before moving on, the normal disclaimer. Well, I tell you that this item was sent for review by GVDA without any costs for me, and I also didn't receive any value from GVDA for making this review. Even so, I should thank GVDA for the channel collaboration. Makes much easier to show you new products and their features, so big thank you for GVDA, and also for you that use the channel affiliate links before paying your purchases on AliExpress or Amazon. Same price to you, big help for the channel. Thank you so much for your support. Without further ado, let's see what this is all about. So let's start by seeing what is delivered. It comes in this box with some info comparing the devices that they have, the 166A. As you can see, one of the differences, it doesn't have DCA 0, so it will not be able to do measurements on DC current, and the others are mostly equal. So okay, let's move on. Yeah, inside we have this black bag. Okay, it seems nice to store the clamp meter. Let's see what we have inside. Okay, delivered, it's a pair of lids. Okay, also the user manual. Let me see how it is. Okay, it's a small user manual, nothing real fancy, but at least it's not too much condensed. It's a bit, but not too much. We have spaced in lines, it's easier to read. Okay, also we have a temperature probe. Okay, and we have our 166B. This is the B model in here. So let's give also a look in the test lids. Okay, this is plastic, it's not silicone. Not too bad, but also not perfect. But I think it has the quality needed for this device. Don't forget, we are talking about a 25 euros device, so yeah, it seems okay. The quality is not bad, to be honest. Okay, let's see also what we have in terms of temperature probe. Okay, it's the normal cable, the protected cable with the probe in the end. Yeah, it seems okay. So let's move on. Okay, it seems compact, very nice. All plastic, we don't have any rubber on this. We have here a light switch and hold button and power button, 3 buttons in below, the function auto, max, min, and select, and in rush. It has a very nice distance to enter the cables in here. If I'm not wrong, it's 3.6 centimeters. We have a holder for one of the lids, and in the back we don't have anything. It uses 3 AAA, I believe, batteries, and we have the connectors for the test lids in the bottom. So nothing much to show. Let's put the batteries in this and start testing. Okay, already powered on, auto mode. It has very nice letters. It's very easy to read. Yeah. So let's see how we can test this. It has here also some light. I believe this is for NCV live detection, something like that. And you have a light, yeah. You have the button and the light in here. Okay, we have something written also on the top, so I believe this is, it has there some writing, and I believe this is the NVC live detector. Okay, in terms of operation, as you can see, we only have 3 buttons, and we have a very nice screen. This screen has a very nice resolution and color. It's pretty awesome to see. In terms of the screen, we have here this selector. Right now we are in auto mode. The temperature on the screen, it's in Celsius degrees and indicates the temperature in the environment. So in the auto function, it will detect automatically what you are measuring, but you can also press the function to activate a different measuring in manual mode. If you are, for example, in amperage measuring, you can press the cell or in rush key to change some parameters, and this happens in the other functions also. As you can see, you have the inrush, AC, and you had DC current before. And yeah, you can move on to different millivolts. You have also the change, and you can move on to different situations, selecting here the other options on that menu if you have it. Not all of them have. Okay, for example, in NCV you can activate the live one wire, one test lead to test it, or the NCV using this sensor to using this key. The key is also used if you pressed for a while in amperage. It's also used to activate the DCA 0. Okay, and press it again for a long press to deactivate. In terms of keys, you have the hold button in here. You can hold it, shows a H on the screen, and it will stop the readings at that point. Press it again and it takes the hold button off the screen. You have also the light that can be activated here with a long press, and if you press it, as you can see, you have this light for example, when you are on a brake box or something like that, to illuminate what you are doing. Also in here you have the button minimum and maximum. It will show you the minimum value and the maximum value that the reading will go. And basically, in terms of the operation, that's it. You have a claw that you can press to test the wire, but I will show you this ahead. Okay, that's it. No, not that's it. There is another issue that I should show you. You can see here on the screen this little icon. This means that the device will auto shut down in 15 minutes. If you want to disable this for working, you just power this off and press the function auto and the power, and then you take the finger out of the function auto, and if everything went okay, it should not appear. Well, it's appearing. No, it didn't work. Let's try again. Shut down. Oops, no. Press function auto, press power, and take the, yeah, and right now you don't have here the auto shutdown symbol. Yeah, and that's it. Let's start testing this. So one of the main functions of this device is to measure the current using the clamp. So that's where I will start my review. I have already here my setup. I have a Tuya dimmer connected to this incandescent light with a switch. Let's power this on and see what values do we have here in the reader. Okay, I will start by powering the light on, I think. Ah, okay, now it's on. Let's connect here. And you can see that is changing the amperage up to 0 and to a maximum of 0.17, I think. 0.16, yeah, it's changing. But as you can see, it's quite precise. It goes up, down to 0 and up again. Yeah, let's try on the other cable. Yeah, it was brighter. Now on the other cable we get basically the same, because it's always the same. Yeah, so it seems to work pretty well. If you connect both cables, it will give you a 0 reading, because you cannot do that. One will null the other. I just pressed here the old, yeah. So that's it. I will test now with DC voltage, but as you can see, it seems to work pretty well. Well, this lamp only goes up to 0.16, 0.17 amps, but you get the idea. So in terms of AC, we are just missing AC measurements. Let's see, I have here a power socket, and let's see what we get. Okay. So normally here in Portugal we have between 230 and 238 and the most, but the normal is 234, 33, 35. So this is exactly on spot on. So for testing the DC current, I will test it with my DC electronic load and my faithful DP832 Rigol power supply. I will start by setting 5 volts on the power supply on channel 1. As you can see, it's already on load. It detected the 5 volts input, and I'm gonna set this like to 1 amp. And let's start the test. You can see that the power supply accuses or detects 1 amp being drawn. So let's see what we have here in the cable. Okay, I have to, it's an AC. Let's change this to DC, and in DC it detects 0.97 amps. Let's see, yeah, 0.98. Okay, let's try the other cable if has any change. In the other cable it detects also 0.98, so pretty cool. Let's put this on again. I will move this to 2 amps. And let's open the channel again. So 2 amps, pretty nice. Okay. It is oscillating a bit, but yeah. It has here some alert. Okay, 197 on 99, 2 amps. Yeah, it seems okay. Let's take this to 3 amps. Open the channel again. And I think 3 amps is the maximum I can take this on this power supply. So 2.3 amps. Yeah, very nice. Very nice indeed. Okay, so in terms of current, I think we have it. Now we can move on to the next test. Okay, so before moving on to the multimeter functions and testing everything in the multimeter, let's first see, since I have here my power socket, how is the NCV reading and the live wire also reading. Okay, to test the NCV, then you just press function auto, this green button, and take you the pointer all the way to NCV live. It will appear on the screen NCV. I didn't mention before, but this 30 degrees Celsius, it's the current temperature. It's pretty hot here where I'm recording with the lights and everything else. Okay, so let's see if the NCV is working okay. Let's bring this to here. You have the low and H that you can observe, and when you are really near, it will show you a red light in here. Yeah, like this. You have also the H here. Right now it's telling you that you have some current around, and you have here the voltage. Okay, there is another function that you can use also to know, for example, let me take this out. For example, if the socket has power or not, you connect in here, press cell in rush. Yeah, and you will have live on the screen. And with live on the screen, let me take the top, you can use it to test the, yeah, you can see it, the live function in here. Okay, this side is live, and this side is this side is common. Yeah, so it works pretty well. Okay, let's take this out of the way. For voltage testing, I have my setup already in here. This is a friend that will make part of future videos also while testing. It's my DC voltage calibrator. I have a second one, it will appear in next videos. But right now I have it connected directly to the GD166B. So, and in the background you can see also my Siglent SDM3045X, very accurate, and it will double check the values from the DC voltage calibrator. So we will start with the voltage. Let's start with 1 volt and power this. Okay, in 1 volt we have 0.997. My multimeter says 0.999. Yeah, 2 digits out, not bad. Let's move on. 2 volts. Okay, in 2 volts we have also 3 digits out. 3 volts, 2.995, and we have 4 digits out. Still, it's the minor digits, not bad at all. 3.993, and in the multimeter, the Siglent, we have 3.99889, since we have a resolution of 4 digits, 4 decimal digits, it's almost 9. So yeah, 5 to 6 digits out, the minor ones. 5 volts, 4.992. In Siglent I have 4.998. 6 volts, 5.991 and 5.998. 7 volts, 6.98, and in the Siglent 6.99, almost 7. 8 volts, so in 8 volts I have 7.97, and in Siglent 7.99, also pretty near. 9 volts we have 8.97 and 8.99. Really good. Okay, let's move on these to millivolts, and we have also manually to change in here. Right now we are DC millivolts, and let's start with 100 millivolts. The Siglent is spot on, and we have here 99.9. Pretty good. 200 millivolts. We have 199.9 and Siglant 200 millivolts. 300 millivolts and 299.8, Siglant 300, spot on. 400, 399.7 and Siglant 399.98. So yeah, pretty near. 5 volts, 400 and sorry, not 5 volts, 500 millivolts. We have 499.7 and the Siglant is spot on 500 millivolts. 600, it's 599.6, the Siglant 600 to the spot. And in 700 millivolts, it's overload, so we have to change the scale again to voltage. So in terms of voltage, then we have 0.698, two digits out. The Siglant is 700 to the spot on, and 0.798, Siglant 0.800, and for 900 millivolts we have 0.898 volts. The Siglant is 900 millivolts, and that's it. In terms of voltage, I think it's okay. Let's just do a quick millivolt check on my board. It starts on 10 millivolts and go on, just to analyze with the other multimeters that I already reviewed. And since we are talking about the millivolt voltage board, let's hear a bit about the channel sponsor PCBWay. Now is the time to talk about this video sponsor, PCBWay. I always use PCBWay for creating my boards with a professional factory quality, as you saw in my millivolt voltage reference board. It is very cheap to manufacture your PCBs on PCBWay. You can manufacture 10 PCBs for only $5. How awesome is this? And it is pretty easy also. Just insert here the PCB dimensions and you'll have an instant code. So when you want a PCB, visit PCBWay to get your code, and if it is your first time ordering from PCBWay, you can use our access link for a $5 credit. And don't forget, they also have component assembly service, 3D printing service and much more. So I have here my millivolt voltage reference boards already set up. You have still in the background in this corner the Siglant, where I should show you every time it's needed to compare the voltage what we have there. Okay, let's start with 10 millivolts. In 10 millivolts we get 10.6, exactly the same value that we have on Siglant. Let's move on to 25 millivolts. 25.2, exactly the same value also that we have on Siglant. Pretty accurate, I'm liking it. 50 millivolts we have 50.1. On Siglant we have 50.17, so it's 0.1 also because we have one less digit in here. In terms of 100 millivolts we have 99.9. On Siglant we have exactly 100 millivolts. In terms of 250 we have 249.9. In Siglant we have 250.09. Moving on to 500 millivolts we have 501.5. On Siglant we have 501.85, very near. And this should be okay, and this should be back to voltage. Let me change it, and yeah, back to voltage. So in 1 volt we have 0.987, and on Siglant we have 0.989. Very good. Going to 2.5 volts we have 2.487, and on Siglant we have 2.490. Okay, very good. And let's see if this one can read the value on the last field. And it can. It's 4.5732, yeah, 57, 570. And on Siglen we have 4.602, 3, something like that. So it's changing. This one, it's not a stable signal, as you know, but yeah, it's more or less the same values. I'm okay with this. Very nice, very nice. For this value, this is an awesome multimeter. Okay, let's move on. Okay, so now let's test the continuity. Okay, let's see. Pretty fast. It takes about 1 second to update the screen. Even the light here is pretty fast to update. Yeah, pretty nice in terms of continuity. Very fast to update. Quite happy. So now we will test some resistance. For that I have already here my reference board. You have the values written here on the board, the reference values, but I will put it also in the screen. So let's start with 10 ohms. (10.1), very nice. If you see, it's 10 ohms spot on. And the second value is 100.03. Let's see what we get. 99.9, not far. The third value is 1.0003 k ohms. Let's see. So it's 4 digits out. Not bad. Okay. 0.999 ohms. The next value is 9.995 k. So let's see what we get. 9.98, really near. And the last value that we have here is 100.06 k. 99.9 k also. Yeah, not bad, not bad. Okay, in the same board we have also capacitors in this reference board, and I will use them to test the capacitance. I already have this moved here to this capacitance symbol, and let's start with 102 picofarads. Let's see what we have, if it detects. Okay, so it detects 0.085 nanofarads. So let's move on to 1.02 nanofarads. Okay, 0.05, really near. And next we have 10.4 nanofarads. 10.4, pretty well. Okay, next one, 98.7, and we have 99.2. Okay, also good. And next we have 929 nanofarads. It's out. Okay, it's 7 digits out, more or less. And finally we have 10 microfarads. Let's see what we get here in the readings. Yeah, 10.6, and the board is 10.0. So we have a little difference, nothing too much significant, but yeah, we have a little difference. Okay, capacitance also good. Let's move on. Now I will take this to frequency. Let's move the pointer to frequency. And for testing frequency, I already connected the multimeter to my function generator. I will start the function generator, and the first frequency that I have here is 100 Hertz with a 5 volts VPP. In terms of duty cycle, it's 50%, so pretty well. Nice. Okay. The limit of the frequency is 10 megahertz, so I will take it there in a bit. Let's start by passing this to 500 kilohertz to see if it can handle. Okay, 49.9, so pretty well. Let me increase a bit the amplitude. It's to see if it increases the precision. No, nothing different. We have a bigger line in here, but in terms of frequency, everything is at the same. Okay, moving on to 1 megahertz. Let's see if we can handle. Okay, we have 999.8 kilohertz, so okay, it's cool, with 48.8 duty cycle. Okay, let's move this to 5 megahertz. We have it 4.999 megahertz, so basically 5 megahertz, only one digit out, and with a duty cycle of 47.8, but it's holding at 5 megahertz. Let's not waste any more time and go directly to the 10 megahertz. So I'm happy, really. We have 9.998, so 2 digits out. Even so, it detects 47.3 in duty cycle. Let's move on a bit to see if we can handle a little more. Okay, 11 megahertz, 12 megahertz, 13. Okay, we are at 20 megahertz. Very nice, very nice. I'm pretty happy with this. Well, the duty cycle, it's changing, but pretty happy. Let's see until we can take this. Okay, I think the maximum is 38. Yeah, when we get to the 38 megahertz, this is spot on. As you can see, the duty cycle changed a lot. It's no longer as it should be on the 50%, but even so, 39, it's no longer valid values. So if you see in the manual, this says that it can take, let me see if I can check that out. Okay, we have here resistance, DC current, AC voltage, and frequency. So as you can see here in the manual, we have a maximum of 10 megahertz. Right now I'm at 37 and I can take to the maximum of 38 megahertz. Yeah, the duty cycle is okay off, but it detects the frequency and it's pretty good to go to up to this voltage. Yeah, awesome, really. Okay, in terms of frequency, that's it. So now I will test the temperature reading. We have a small difference between this temperature reader that I have. I have to confess that I don't trust much in this temperature reader, but the difference between both devices, it's not so far away one from the other. It's like 1 degree or something like that. Right now I'm using my hand to get the same temperature. You see that I'm using the same fingers. So yeah, it's almost there, 33.9, 33.8. Let's wrap this up. I will start with the price. At 25 euros or around $27 is in the middle of the table of what you can find on AliExpress. But since the functions may vary a lot between models, this might be not an accurate comparison. But I will say the price is good for the quality and functions of the device. In terms of design and case quality, it is compact, and even without rubber to protect it from a fall, it seems very robust, made with quality and durable plastic. You have a very large range of functions available in most multimeters, from AC and DC current measurement, and be aware that not all current clamps can measure DC. For example, the GD166A only measures AC current. So you have AC-DC current measurement in the clamp, voltage metering, temperature, resistance, capacitance, and so on. Well, you saw it in video, I hope. The light is also a nice touch for when you have to use it in low light environments like a breaker box. Overall, it was a very positive experience I had in the review, and this one will be to keep around in my toolbox. So, if you feel inspired to acquire one of these GD166B, please remember that you have the affiliate link in the description or the access links here in the screen. No extra cost for you, but a big help to the channel, and you will be well served with this clamp/multimeter. And if you learned something with this video, please spread the love and slap that like button. Hit that bell to activate all notifications if you want to be one of the first to be notified whenever I upload a new video. That's it for today. Thank you for being with me, and I hope to see you in my next video. Stay safe.